Welcome to the next episode of the Anti-contractor Home Podcast. I'm Chance.
And I'm Belinda.
And today we're going to talk about outdoor electrical. What does that mean, outdoor electrical?
So outdoor electrical would be, just in terms of the home, would be everything from power pole line coming to the house. But I'd like to go a little bit into where that actually comes from. Maybe just trace it back to the substation. Don't have to go into how electricity is made, but just trace it back to the substation, the voltage that comes to your home, what the purpose of a transformer is, because we might have to actually buy our own transformer.
Or we could make one. So this is going to be more of an informative episode where we're discussing a lot of the basics of electrical and what the electrical company provides to you and how that gets to your house, not discussing
Electrical work inside the house.
Yes, like your panel and hooking up your lights or anything like that. That's reserved for a future episode.
Yes.
But for now, we're just focusing on that line, getting that service to your main panel. So our goal is with the Anti-contractor Home to keep things as simple as possible, as low maintenance as possible. And we've discussed plumbing, waste, and water coming to your house. Another thing that has to come to your house, in most houses, is electrical.
And some cases, gas.
Some cases, gas lines, yes.
Yeah.
In our opinion, we've had a little bit of experience with gas lines, not really running them, but using gas in your house. Our furnace is gas. Our water heater is gas. We've used gas stovetops, things like that. But there is this, I don't know,
out of control aspect.
Yeah, you can say that. Well, your gas could make your like a gas leak could make your house explode. Well, electrical could burn down your house too.
Yeah,
Plumbing could flood your house.
Cool? So growing up in Dubai, back then they didn't have a main gas line running to all buildings. So the apartment building that we were staying in, they had like a light well almost going all the way to the basement. We had a 3-story building, and so we had a tiny little balcony right outside our kitchen, very tiny balcony. We just had to call a company and they would bring a gas canister.
Like a propane tank?
Yeah, like a propane tank. And they would connect it right outside the kitchen. And that's all the gas connection was. We didn't have gas lines through the city, nothing.
That's probably pretty common.
It's kind of scary to think about it now. You're like, oh, there's a gas tank outside.
There's a propane tank, yeah. I mean, whenever I was living in an RV for a little while, that was my only source of heating the RV was
the propane tank.
Yeah, propane tanks. And then if you needed it, I had 2 propane tanks. And when one went out, you disconnect it, take it, and refill it with propane, bring it back. And so you had 2 tanks, and you ran off those 2 tanks. So in Dubai, y'all would run. Did you have a gas stove?
We had a gas stove. That's the only gas connection we had in the house.
Okay.
So there was a line running right from the gas stove to that little balcony outside the kitchen,
So is it still that way?
Every couple of months, it's still that way.
They still haven't run.
But not in the new construction. I think now they have gas lines, but since our home was, I don't know, they were built in the 70s, late 70s. So that's the way it was done back then. So simple. So
why are we anti-gas? Gas is pretty sweet. It's pretty cheap. It's gas stovetops are hard to beat. I mean, I just love how quick things heat up with gas stovetops.
Very efficient.
Yeah.
Cheap. Well, for me, it's 2 things. One is non-renewable resource. Like electricity can come from a renewable resource.
Right. Can.
We don't know whether it is what percentage, but the States is moving towards more renewable resources, and you don't realize that a lot of your electricity provided to your home is actually renewable.
Yes.
It's not coming from burning fossil fuels.
And you can actually specify plans that are 100% renewable, where all your energy comes from renewable resources.
Yeah. So then that's one of them. We want to be more environmental friendly. The second for me is the danger of having a big gas meter out there, because when we had that big tornado come through, the guy who came to check our gas meter said that a couple of homes right in the path of the tornado, the entire meter was just blown off. And he was talking about the pressure being released from those, and how they had to bring in special teams just to cap all those lines and fix that. That's
right, because
really
the line
dangerous.
was, you were getting the full 20 pounds per square inch, whatever it is.
PSI, yeah.
Yeah, coming from the main gas line because there was no regulator there to
Correct.
to
The
drop
regulator was
that
just blown off.
pressure.
That's scary.
It is very scary. Yeah, the idea of
Like with the propane tank, you have or a natural gas tank or whatever. It's a limited amount of. So if you have a leak or something, it's a defined risk.
I worry about the combustibility
Yeah.
of it. I mean, we have gas ICE vehicles, internal combustion engine vehicles that run on gasoline and they're combustible
Yeah.
and they're sitting in our garage.
Yeah.
I'd like to get away from that, but gas is pretty cheap sometimes, but it goes back to it not being renewable.
Yeah.
So that's sort of our stance on gas. So we would like to
We understand the advantages of it, but
and the potential of being fully off the grid, not fully because of water and sewage,
off
but
the grid in
being
terms
off
of
the grid
electrical.
electrically, powering your home from off the grid is not possible.
If you're reliant on gas.
Yes, if you rely on gas, you always have that connection to the gas company.
Yeah.
Let's talk about electrical
basics.
in general. Yeah, the basics of electricity and how it works. Some of the basic terms, the
Terminology,
units,
yeah. Because
things like
everyone
that.
talks about voltages, amperes, and resistance, but what does that actually mean?
Yeah, it's all really confusing. I mean, even if you're privy to the basics of electrical, still trying to calculate how many amps your panel can hold and things like that.
Yeah, because it's not just a sum of things.
Right.
It's more complex than that. So voltage is difference in electric potential between 2 points of a wire. To understand it, let's use a similarity with water flowing through a pipe because that's an easy way to explain this.
I like that comparison because I'm more familiar with plumbing and
Yeah.
maybe that's easier for people to visualize.
Yes,
electric,
because it's a very abstract concept.
Yeah.
What is like a physical thing?
the pipe size water analogy.
Yeah. So voltage is the water pressure going through your pipe. That's the same thing as voltage.
So you can push that's unlimited. Like you can push as much pressure as you want through that, much voltage through that wire as you want.
It depends on the resistance and amperes, which is what we're talking about next.
Okay.
So
Jumping ahead.
current or amperes, amperes is the measure of the current. So that's the rate of flow of charge. So the rate would be the amount flowing per second. So how much water is flowing in a particular period of time,
Okay.
right? That would be rate. So voltage can be thought of as the force that pushes electrons through a conductor. So it's the force of water flowing through a pipe. So the greater the force the greater the voltage means that there's a greater ability to push water flowing through a pipe. So a lower voltage means that you're receiving less amount of water or current, but a higher voltage means you're receiving more electrons, basically.
More pressure. Yeah, more water pressure
water.
in the analogy.
Yeah.
So I've seen the graphic analogy where you have basically a big water tank and it's filled up and that's your voltage. The water tank being filled up is your voltage. And then you have the pipe down at the bottom and
you
that's
release
your
that.
amperage, the flow going
The
through
flow.
that.
How much is
and
flowing.
you can release as much as or that's defined, I guess. It
And
releases.
then resistance would be the material of your pipe. If it's more rugged or something, it's preventing water from flowing. Or a size of a pipe, like a really small pipe would have less water flowing through than a really large pipe.
So a good analogy to that is like water flowing through a river. If it has lots of bends and breaks, that current is going to, or there's going to be more resistance. Or if you were to look at pipe with water flowing through pipe, if you have more fittings, more elbows, more turns, there's going to be much more resistance. So the same thing can be said in electrical.
So using copper versus aluminum or using another metal might have greater resistance. So that dissipates electricity in the form of heat. So you're losing electricity by the time it comes to your house.
Yes,
That's
which is
what it
why
means.
copper and aluminum are most frequently used. Yes, silver has higher conductivity, but it's much more expensive.
Yes.
So you'll see copper and aluminum frequently used.
So conductivity would mean low resistance. That's what
Yes.
you say. Yeah. So all this electricity is produced at different plants. You have the gas-powered electric plant. You have hydroelectricity. You have solar plants. All this, and since they're all producing alternating current or AC current, you can combine all these different sources of electricity and then send it out to the home grid, your electric home grid. These main power plants, they actually have to step up their volts because of loss of electricity through power lines, because we don't have a metal that has zero resistance. We are going to lose electricity in the form of heat while this electricity has been transported through power lines. So
Okay.
they have step up transformers at these power plants that increase voltage from 155,000 to 765,000 volts,
Which is a lot.
which is a lot. So the big transmission lines that you see, the really big ones,
Right.
that's all carrying 750,000 volts in each line.
Right. You don't want to touch those.
No, you don't want to touch those. So the maximum transmission distance is 330 miles. Once you, when you're close to that, you have to step down. You have to go to a substation.
Okay.
You have to go to a substation, step that down, and then if you want to continue over to another main power line, again, step it up, and then
So the basics are the power plant produces electricity.
yeah,
They send it at
substation.
765,000 volts
to a substation.
to a substation. Substation steps it down.
Again, to 72,000 volts.
And then from the substation.
And that's what you see in those power lines outside your homes, in older homes. Newer homes, it's all underground. But that's all 72,000 volts
That's coming from the substation.
from the substation.
Okay.
And
It's
then-
not step down again?
No, right? At those wooden power poles, there's another transformer that steps it down from 72,000 to 240 volts.
In our case, about a couple hundred feet away is a transformer that I assume the power lines are coming from the substation to that transformer. That's where it's being stepped down. And then the power lines that are actually going right over our yard
That's
are
240.
240 volts.
Because that can feed several, about 4 to 6 homes. That's what I read.
Okay, 240
So in
volts can.
older neighborhoods like ours, that feeds more than it technically should. That they recommend just 4 to 6, but in older homes, it feeds more.
So they have to have one of those transformers that it's not a huge transformer like you would see in a substation. It's just a big metal box that's
Yes.
sitting in your neighborhood. They have multiple of those
Yeah.
around because each one of those feeds 4 to 6 houses, maybe.
Yeah.
Something like that.
Yeah, and you can also see it sometimes on the wooden poles. There's a metal box mounted right on the pole.
Yes.
That's the step down transformer.
I'm guessing that the substation goes to that big transformer out there, and then from that
There.
transformer, step it down, and then that transformer is stepping it down because
so
the ones
this
you
is
see,
240. That main one's still
Yeah.
higher than
yeah.
that.
So the ones you see on your poles, those are the
That's the-
240
yeah.
step down transformers. So
that would make sense because otherwise you're losing so much
Right.
if they're trying to step it down way over there. And
yeah.
then,
So no telling what that
No.
transformer is stepping it down to.
so it's
but,
something between 72,000 and 240.
right.
Yeah.
So it can feed that transformer that's on the pole, the
Yeah.
cylindrical one,
Yes.
can feed 4 to 6 homes approximately. Yeah. So that big transformer is probably feeding this whole neighborhood by going to these different transformers
Yeah.
and stepping down. So our neighborhood, our house is 1960s home. So every house in our neighborhood is connected overhead
Yes.
lines because that's the way it was done for so long. And I guess the past 20 years or so, you're starting to see a big trend moving towards underground power lines. That's
Definitely.
mostly due to the wind and weather damage that happens to these overhead power lines so frequently. I mean, whenever you get a storm, I mean, it's pretty common that your power is going to go out with these overhead lines.
So in the long run, you just end up paying more to
Yeah.
fixing all those
For
overhead
example,
lines.
we had a power outage for a couple of days at our house, and my sister, who lives in a new suburb where all power lines are underground, they did not have a single power outage, but
We
even
had for maybe an hour.
Yeah.
But that's it.
yeah, so it's much quicker to repair. The damage is usually less
Extensive.
extensive, yes. And I wouldn't say it's much quicker to repair, because if you were to have damage with an underground power line, you would have to dig a trench and fix it.
Yeah.
So speaking of the advantages and disadvantages of underground versus overground or above ground, the above ground power service is going to be less expensive. It's more susceptible to wind and tree damage. You have squirrels running on your lines. The power outages, like we said, can be much longer because the damage can be extensive from debris.
But you think it depends on the neighborhood that you're in? So if you're in like an HOA, a neighborhood that has an HOA, and you're building a new plot of land, they might say, nope, you can't have overhead power lines. You have to have it underground.
Probably, yeah.
So all these power lines that come to your home, you see all of these like 120/240 volts. You see that a lot. That's what's in North America. So that means that there are 3 wires coming from that transformer right there, right outside your house. There are 3 wires coming to your house. There are 2 hot wires and 1 neutral wire. Those 2 hot wires each carry 120 volts, and they're out of phase with each other.
What does that mean? They're out of phase with each other?
Out of phase with each other. So it's alternating current, so it keeps switching back and forth. So when one is in one direction, the other 120 volt wires carrying the current in the other direction.
Okay.
There's a really good video on YouTube that explains how this works, the 3 wires coming to your home.
If you were to look at your panel in your house, if you were to take off the cover, which I don't recommend doing that, but if you were to take off the cover, you would see 2 large black sleeved wires coming in, most likely aluminum, could be copper, into your panel. And then the neutral wire, I don't know where that...
So the 2 in the middle that overlap each other, those are the 2 main bus bars. That's what the 2 hot wires go to.
That's
and
the
then,
copper plate, right?
That's the copper plate.
Okay.
And then there are either 1 or 2 neutral bus bars on either side, and that's what the neutral wire goes to.
And then there's a ground bar at the bottom.
And then there's a ground bar at the bottom.
So the 2 hot wires come in, connect to those 2 copper plate bus bars, and then you have your neutral coming in, connecting to one of these side bus bars.
Yeah.
Why do you have 2 side bus bars?
So your ground bar can either be on this one side or it can be on the bottom.
Okay, so you only have one
neutral
and one ground.
One ground.
Okay.
Yeah.
And which all houses nowadays need to have a ground
Grounded.
panel. What do you do if you were to build a house? You need to get electrical service coming to your house. What do you do?
So you have to find the provider in your area who provides electricity in your area.
Okay.
So what I read is that there are 3 parties involved in providing electricity to your house.
Yes.
There's a retail electric provider, the first. And for us in this house, that's Ambit. So what Ambit does is they send you your monthly electric bill. They sell electricity to consumers.
Yes.
They may not actually produce the electricity, they just sell it to us. That's what Ambit does. So then the second one that I read about is an electric utility company or a transmission distribution utility. It used to be called electric utility companies. They've changed the name now to TCUs. So that in our case is Encore. So what Encore does, they transmit and distribute electricity to your home or business. They maintain poles, wires, meters. They also measure the electricity consumed by your home or business. They read the meters. So what's the relationship between Encore and Ambit then?
So does Ambit buy electricity from Encore?
If they're selling electricity to consumers, then I guess they're buying the electricity from Encore and they're selling it to us.
I always wonder this, like whenever you get an apartment or a house or something, you have to have your electricity hooked up.
Yes.
You have to.
It's never just one company.
And sometimes in apartments, you are restricted to one company.
Yeah.
But I think they've sort of opened up the power to choose. You can pick your own retail electric provider. Mm-hmm. And so you compare quotes online. I mean, you can spend days doing that, and they'll tell you how much they're going to charge you per kilowatt hour. But then from there, if you were to look at your electric bill, you'll see that there's these extra charges from your TCU, in our case Encore. So there's like an Encore charge.
That you cannot pick because I believe that's they've designated
Yes.
areas to those companies.
Encore covers most of Texas.
So maybe they do the dealing with the consumers and
Yes.
all the paperwork and
Right. So it makes me
all that
wonder like
stuff.
why Encore doesn't
take
have
on
a
that.
retail electric provider. Like why?
Maybe they are linked.
why does
Encore
it
and
work
Ambit?
that way? Maybe it was some sort of government legislation long ago that said, hey, Encore, you can't be a monopoly.
Yeah.
Or whoever the TCU is can't be a monopoly. So you got to give this guy, this retail electric provider, a share or
Yeah.
something. I'm not sure about that, but that's the way it is.
And
You can't
there's-
bypass the retail electric provider.
No, you can't. But sometimes you may also have to deal with a third company.
Yes, I'm not familiar with this.
This is a third service provider. So the third party service provider provides services to consumers related to energy use, such as monitoring energy use, consumption. Your third party service provider can either be your electric service provider, which is Ambit.
Your retail electric service provider. Yeah, I'm not really sure what a third party service provider is. I've only dealt with retail electrical provider, and I haven't directly dealt with the TCU, but
Yeah.
you're always aware of the TCU because that's a nice hefty chunk of your electrical bill.
Mm-hmm. Have you heard of Griddy? So they differ from Ambit in the sense that
And let's not use Ambit too much because
Yeah, it's the
not too
company.
happy with them. Let's just say your retail electric provider. It could be Reliant. Well, in Texas, Reliant,
What other companies are
Ambit,
there? Yeah.
Green Mountain. There's so many different.
Oh yeah, I found this website called powertochoose.org. So if you type in our zip code,
Mm-hmm.
you see all the retail electric providers in the area. So if Encore might be the only one that maintains
Encore
the
is
poles,
the only
it's the only
TCU.
one, but there are like 100 different retail electric providers that you can pick.
So what is this Griddy?
So Griddy, it kind of-
GRIDDY.
it's a way for you to micromanage your electric consumption. And it can be very overwhelming.
That sounds like the free nights and weekends. I would be micromanaging
Similar.
my electricity.
But you have the peace of mind saying, okay, overnight on weekends, I'm not paying anything. With Griddy, every hour of the day, the cost of your electricity changes throughout the day. So every hour, every time it changes, they're constantly sending you notifications. So if it spikes up to 9 cents or if it drops down to like 0.3, they're constantly telling you what your rate is so you can change your consumption accordingly.
So Griddy is a retail electric provider?
I don't think so. I think they're third party service provider.
So
So they look at the rates provided by different retail electric providers at a particular time, and they provide you with the cheapest rate.
But you can't. You're locked into a contract with your retail electric provider. Like you can't just change your electricity every hour.
But that's what they do. So they said wholesale electricity prices change every 5 minutes depending on supply and demand. I was saying every hour, every 5 minutes.
Okay.
So they send you push notifications every 5 minutes or whenever it changes, telling you what your price of electricity is.
But you don't care. Like,
Well, if it's spiking to like 9 cents per kilowatt hour,
can you do
turn off
something about
anything.
it?
No, you're stuck with them. No matter if it's 9 cents, it's 9 cents. So that's why there are a lot of unhappy people because
So it's really just information. Like they're saying, hey, your rate's up to 9 cents. Hey, your rate's down to 6 cents. Hey, your rate's up to 13 cents.
Mm-hmm.
So, okay, so maybe I'm getting it now that whenever they give you that notification and say, hey, it's up to 13 cents, that's an incentive for you to turn stuff off.
Yeah.
Okay, so they're a retail electric provider, but they're just saying, hey, your rate, you have a dynamic kilowatt hour rate.
I thought it's that they try to find the cheapest rate and provide you with that.
I think that's what they're
doing. So they claim that by only paying wholesale price, it's going to be 22% cheaper than Texas average, but that's not what consumers have seen.
Okay.
People are very unhappy. They have noticed their bills doubling and tripling, and
Yeah, because I mean, if
stuck
it
with
changes
them.
every 5 minutes, you get this notification 5 minutes late, and you say, "Okay, I want to turn off my, my furnace now."
Mm-hmm.
And 5 minutes later, your rate just went down, or maybe your rate goes down, and you say, "Yeah, I can turn my furnace on now and my stove," and you turn it on, and
5
oh,
minutes
by the
later,
way,
yep.
your rate just doubled. So, Griddy is. I don't know why we're promoting them so much. No, we're not
You're
promoting.
not promoting them.
It's interesting because it's a different concept.
Yeah.
Maybe their intentions are good. Their business model is not fleshed out yet. Let's say I have a plot of land. I want power. What's the process I have to go through to do that?
So I went to this website called Entergy,
Spell that?
Entergy.
Okay.
So that's the only website I found that talks about establishing electric service to your new plot of land.
Because
So-
sometimes you have to make phone calls and figure things out.
Yeah. I don't know if the other ones that's another company that you have to contact. I don't think Encore or Ambit is going to help you establish, like bring in power lines and everything.
I would think so. I would think my thought, just from my experiences with apartments and then now a house, it's okay, you're moving to this area. Who's your retail electric provider in this area? There's your option of 78 companies. Okay, you pick your one company that you like, call them. They say, okay, we can turn the power on in your area. Oh wait, there is no power line in your area. Mm-hmm. We need to contact your TCU or the TCU and get a power line or a power pole put in, a transformer, a power line run to your house or to your plot of land? Or do they say, hey, there's no service going to this plot of land. You need to contact Encore or your TCU and get that to your property first. Then we can help you turn it on. We can help you flip the switch because that's all we do.
So I just went to Encore's website, and they say that Encore is the only company that can deliver electricity and gas to your area if you live in the Encore service area. Supply, on the other hand, is deregulated. Supply is the purchase and sale of energy from wholesale markets to retail markets, and 85% of Texans can choose their own retail energy provider.
Okay.
So that's a deregulated
So
market.
Encore is regulated.
Yeah,
And your retail service provider is deregulated.
deregulated.
That's why they're all different.
Yeah.
Let's talk about preparing to get electricity to your house. You have to make some considerations beforehand. Mm-hmm. Going back to our discussion about no gas lines,
Yeah.
more of our house, or all of our house, 100% will be electricity. Everything will run on electricity. So we have to consider how much service we're going to need provided to our house. So it's probably a good practice to understand what your overall
Consumption's going to be.
consumption's going to be, and understand also what your peak demand is going to be.
Yeah.
Because you can design your house for
200 amp.
200 amp panel, but you may only be using 50 to 70 amps at any time.
Yeah.
And that you may be way oversizing your panel, which would cost you more money. Now, if you're looking to, like us, have everything running on electricity, including
A car.
vehicles in the future, like charging stations in the garage, future-proofing your panel is beneficiary.
Yeah. And there's a chart that you can look at to try to calculate your breaker size.
Okay.
So you calculate your total,
Panel size?
Your panel size.
Okay.
You calculate the total needs by multiplying square footage times 3 watts, because I think that's the number of receptacles in each room. They multiply that by 3. And then you add 1,500 watts for each kitchen circuit that you have, because that's different. So then you add up add the wattages of all your appliances. But it seems pretty straightforward. You just do these calculations and you can figure out what service
It's not
panel you need.
I mean, it's not. It's just a rough estimate.
Yes.
I mean, if you have the money, you can oversize. I would recommend oversizing for future proofing, because it seems like we're moving towards more electricity.
You think new homes are all just 200 amp panels?
Depends on the size of the house,
Yeah.
really. But I would imagine
Like an average suburban
the
home.
big suburban homes, they're 200 amp. Sometimes they may be a 200 with a sub panel connected to it.
So what are subpanels?
Subpanels are very self-explanatory. It's a smaller panel that feeds from your main panel. Because your panel has so many slots for breakers, and if you run out of slots on your panel, you can take one slot and, let's say, put a a 50 amp breaker in that slot and feed that to a subpanel, and that subpanel can have up to 50 amps of breakers in there, so you can basically expand your slots.
Yeah. But you have to make sure that you're able to handle all that. You can't just
it's
add
so
another
like
panel.
if you had a 100 amp panel and you added a subpanel that was 100 amps and you filled it up, you would probably be
overloading
overloading your breaker.
Yeah. So in our home, what are you thinking? We have the main 120 240 line coming in. Are you thinking we have one sub panel in the garage for the water heater, the laundry, the cars? That's one sub panel there. And then another panel in the house for all the interior needs.
I like the idea, since our plan is to run the electrical wiring in our house on our own. Mm-hmm. I like the idea of being disconnected from the main electrical service. So providing an extra disconnect switch in between your panel and the service provider would make me more comfortable working inside the panel. You could run your service from the electrical company to your house to a main disconnect, and from there you could feed multiple different panels, or you could feed your one main panel so that you would have a clear disconnect between your main panel and the electrical service, the hot wires.
Yeah.
And so you could have your main 200 amp panel and have sub panels coming off of that to have access to those breakers. Like you had mentioned, having one in the garage, a sub panel in the garage, or a sub panel in a workshop or something.
Yeah.
But that's really for convenience.
Would be a safety thing if you are traveling? Would that help, like turning off some breakers and just having one breaker on?
Like, let's say you had a sub panel in your garage that had, like you said, a couple of 30 amp breakers for cars, and then maybe a couple more for big power tools or something. You could turn all those off. If you're going out of town, you're not going to need any of that running.
Yeah.
But then you could still have your house electricity flowing through your house through that panel.
Yeah.
The main thing I would like is to have some sort of disconnect between those panels and the electrical provider, because if you're to open up your main panel, you have those two 240 volt wires coming in that are always hot.
Yeah. And
the only way those are not hot is if you were to call your electric service provider and tell them to shut off your electricity.
Yeah.
Otherwise, if you touch those in your panel, those are fatal. Mm-hmm. That would be fatal. So
so you can work on the house, work on wiring, and then still have that main thing shut off. Yeah. So I have a question. They tried aluminum wiring in the 70s, but there were lots of house fires, so they decided to ban it. So no homes now have aluminum wiring inside the house, right?
I'm
saying
you're asking me that?
No, I'm telling you.
That's fact? Okay, I didn't know that. I thought that you could still use aluminum wiring.
No.
I guess it's a grandfather, if you're grandfathered in?
Yes, if it was built in that time, then that's fine, but now they don't allow it because there are too many house fires.
That was a concern with
this house.
Our current house, yeah.
So
our inspector told us, no, it's copper wire. It's not aluminum wire, because it's so old. We thought maybe it would be aluminum wire, which the big negative to that is resistance. You're losing.
No, I think it heats up much faster. So it has a higher resistance than copper. Mm-hmm. So it heats up much faster and can cause house fires.
Okay.
So that's why they don't.
And it's much less efficient.
Because resistance is higher.
Yeah. So it boils down to the resistance of it.
Yes.
Yeah.
So why do they still use that from your step down transformer to your house? Like I was looking at wires coming to your house, and they were talking about, okay, if you have a 100 amp panel, 100 amp breaker in your house, you either have to have a number 4 copper wire or a number 2 aluminum wire. If you have a 200 amp panel, you either have to have a number 1 copper wire or 2 number 0 aluminum wires. Why are they still using aluminum? It's cheaper, I get that.
Is aluminum illegal to use, like, in your house?
That's what I thought.
Because I've seen people use aluminum just because it's cheaper. So I think it's strictly the cost, because copper is significantly more expensive than aluminum.
Yeah.
And they're running so much of that wire that you might have during a power outage, you might have some crazy people actually going and cutting those power lines and stealing the copper like they do off job sites when they go steal copper pipe and sell it.
So because it has a high resistance, people had to use a larger wire. So instead of a 14 gauge copper, they used a 12 gauge aluminum wire. The issue is that it's a softer metal than copper. It heats up and it rusts.
It rusts.
So this website I'm looking at says it's a myth that it's not legal to use it.
Okay. Because I've seen some DIYers out there on YouTube that
They use aluminum.
they're actually running aluminum wire because it's much less expensive. You just have to upsize.
Yeah.
I understand running your 14 gauge, your 12 gauge, going to your receptacles, things like that. In copper, it's going to be much more efficient. But when it comes to that number one wire or the aught wires, those in copper are very expensive.
I want to look this up. They say in the mid 60s, the price of copper was sky high. What was it?
Let's see.
And then it just came down since then?
So looking at commodity prices for copper, 1959, it was 29 cents. In the 60s, it basically doubled. It went from 30 cents to 60 to 70 by 1966. But it's continued to go up since then.
Oh.
I mean, that's probably mostly due to inflation. But 60 cents to the 90s, it's $1.34. And then 2000s, there was a big jump from 64 cents to $3.26 to around the financial crisis in 2008. And it's peaked as high as $4.28, and it's sitting around $2.75 to $3 now. Copper is.
Wow.
So there's a couple of good video references. I mean, there's tons of them on YouTube. We're by no means electrical experts. We're just very interested in how we can run it to our house. We want to know the process. We don't want to just call the company and say, hey, do it all
for
and
us.
here's 10 grand, figure it out.
Yeah.
We want to know the process. We want to know that we're not being taken by the contractor, because you will inevitably have to hire somebody to make that electrical connection, that main connection.
You can't do that by yourself.
Yeah. So there's a few good references out there on YouTube. I know we spoke about him in our last podcast, Mr. Homemade Modern. He's very thorough, fellow architect who really knows, who really does a good job of breaking down the cost and the exact process you go through.
Yeah, because he had to buy a step-down transformer for his plot of land and then run the wire, underground wire, I believe, from the transformer to his house because he didn't have service there.
Yeah, so there's a couple of good video references. We'll provide a link in the description to those videos.
Yeah.
And because you do have to deal with a contractor, and the only way you would not have to deal with a contractor or that electric service provider is to go completely off the grid.
Yeah.
Where 100% of your electricity you produce on site.
Yeah. Which
the popular method, the most common method, would be through solar, especially in Texas. So next week we'll be discussing solar panels and the off-grid option for the anti-contractor home. Thanks for joining us. I'm Chance.
I'm Belinda.
Bye for now.
Bye for now.